So welcome to this session by Makers Empire, an introduction to 3D printing. We will be recording the session, so you will be able to watch this later. We will blur out people's faces though, so feel free to leave your camera on. And I will hand over to the lovely Mandy, who will be presenting today.
Thank you, Abigail, and welcome to this session, which is an introduction to 3D printing, presented by my team, Makers Empire. I'm Mandy. I'm the Director of Learning at Makers Empire, and I'm also joined by Luke, who's our hardware specialist, and we'll be sharing the session today. Do you want to say hi, Luke?
Hello, everyone.
Thank you. So I think it's best to keep our microphones off during the session, turn them on when we need to, just to cut out any background noise. Use the chat function if you need to let me know anything or have any questions. If you want to leave your camera on so we can see your lovely happy smiles, that's great. And Abigail is recording this session so it can be shared with others who weren't able to attend the live session. I'd like to begin by acknowledging that I'm running this session from Ghana land, and I would like to pay respects to the ongoing and deep connections that Ghana people have to land and country. And when we're talking about asking our students to be creative and innovate and use new technologies to solve problems, as in 3D printing, it's important to remember that we can draw upon many thousands of years of the First Nations knowledge. First Nations people have always used available resources to solve problems, to live in sustainable ways. This lovely image is from Corey Tutt's book, The First Scientists, which reminds us that our Aboriginal peoples in Australia are the world's first scientists, the first people to use the world around them to solve problems, to make meaning and understand their environment. In this session today, an introduction to 3D printing, Luke and I would like to unpack what 3D printing is, some of the current and emerging applications of 3D printing with Makers Empire, and then I'll hand over to Luke to have a look at how we work with schools with 3D printing and the technologies that we use. And then I'll share what we see as some of the benefits with the schools that use 3D printing, particularly in a primary, middle school level. And I'll share a few examples, and then we'll open up for any questions and discussion that you might have. So to begin with, I'm going to play a quick game. This is a game that I like to play with students when I'm introducing the idea of 3D printing. So I know, Leanne, you're the only one on the call, but pay attention because I'm going to throw up some pictures of things that people have made, and they'll flash up quite quickly. Here we come. You just saw 8 things that other people have made. Can you have a go at remembering how many things you saw or what the things were? And if you'd like to pop your number in the chat, how many can you recall? Abigail, you can have a go at this if you like. Luke, you can too, but you're at an advantage because you've seen it before.
Can't find the chat. Hang on.
Up the top.
I think I got it. Yep.
You got 6, Luke. Abigail got 5. And how did you go, Leanne? How many did you recall?
6.
Oh, excellent. And here they are. Ah, that's the one I forgot. So when I'm doing this with students, I then ask them to have a chat about what these things that people have made have in common. And I start to look at the materials that have been used, the things, the shapes that have been used, the function, of these objects, and sometimes they look at the relationships between things such as cutlery for eating pizza. But of course, one of the other things that these objects all have in common is that they have been 3D printed or have 3D printed parts, even the pizza. So 3D printing uses a particular process for creating things that we'll talk about in a minute, but it can use a whole range of materials, even food. So that pizza base has been created using a 3D printer, and you can even get 3D printers from Hershey's and Cadbury that 3D print in chocolate. The go-kart is a high school project, and that's been 3D printed in parts and then assembled later. The jawbone, and it's the jawbone there that has been 3D printed, not the teeth. But having said that, dentists are one of the biggest users of 3D technology. And I know I've got a 3D printed crown that my dentist made for me. I was pretty excited about that. Not excited about needing a crown, but excited that he created it using 3D printing technology. He took the scan of my tooth, created a crown using a special 3D printer in his clinic with me there, and was able to then implant that into my mouth, and off I went. It was still expensive, but it was much quicker and much less hassle for me. I actually thought that should be tax deductible because it's kind of work related, but maybe not. But anyway, in that picture, it's the titanium jawbone that has been 3D printed. And this jawbone belongs to an elderly lady who lives in Melbourne, and she had a diseased jaw joints, which was making it really difficult for her to eat and talk and drink. Her surgeon worked with a designer, and they were able to create an exact replica of her healthy jawbone and to be able to be replaced. Obviously a pretty full-on operation she had to have, but then she had this brand new titanium jawbone and was able to eat and drink and talk as she liked. The dress there in the middle comes from the collection of a young fashion designer from Tasmania, and a few years ago she showcased her entire collection using 3D printed materials. That particular dress is made from thousands of 3D printed butterflies sewn together to create this dress. So designers and artists are experimenting with 3D printed materials to create different textures and effects. The bicycle there is the frame that's been 3D printed, and I don't know if you can see it in this picture, but it's kind of a meshy look, and that was an experiment trying to create a strong but very light frame with the hope that you could go faster on it, make a faster racing bike with a lighter but still strong frame. And the house there is also 3D printed. So not with food, not with plastic, not with titanium. This is actually 3D printed with concrete or cement. And it's the same technology, the same process, but with a really big cement 3D printer. And one of the things that excites me about this example is that this particular house was 3D printed in under 24 hours for $20,000. So if we can create houses this quickly and this cheaply, it makes me start to think, how might we use that to solve problems around homelessness or responding after a natural disaster when people have lost their homes. This particular house, it was the world's first 3D printed house by a Chinese company, but we now do have companies in Australia, one notable one in Melbourne, who are 3D printing houses. So there's lots of examples. Does anybody on the call have any examples that they have heard of 3D printing being used in interesting ways? Luke, what's your favourite example?
That's a really tricky question because, yeah, there are quite a lot of things. I think one of the most intriguing uses of 3D printing, if anyone here has ever heard of, or maybe they have, Invisalign, or I think it's another company called Smile Direct, the sort of clear braces that you can have over a 6-month course. They're actually 3D printed in Texas. So they'll take a 3D scan of your teeth, and they'll sort of digitally conceptualize what your teeth should look like, or rather what you want them to look like. And then they can use the software to sort of go from point A to point B, and all of the various braces in between that you wear for 2 weeks at a time. And yeah, that's how they do modern bracing.
Wow.
Effectively. Yeah.
Excellent. There's some really great examples from all fields of medicine, really, aren't there?
Mm-hmm. Yeah.
Does anyone else have heard any examples of 3D printing being used in interesting ways?
I'm not 100% sure, but it looked like it was 3D printed. But my dad had to have radiology, and they made a mask to go on his face, and it looked like it was 3D printed. So I think it was.
Yeah. Well, I'm pretty sure that they are 3D printing things like that. We saw some stuff like that at the Advanced Design and what was it called, Luke, in Griffith University? ADAPT. They were making something like that for radiotherapy when we were there. Yeah. Excellent. Very interesting. I hope your dad's okay.
Well, I can take a picture of the mask and send it to you, Mandy.
Yeah, very good. Thank you. All right. And there's even a 3D printer in space. So here we see an astronaut installing the 3D printer on the International Space Station. And they use this on the ISS to print maybe replace broken parts or tools that they might need, because obviously they can't take everything they might possibly need with them. And they can't take lots and lots of rolls of filament, which is the consumable material that's used with a 3D printer. So they have this amazing machine called the refabricator, and what they do is recycle any plastic, so food wrappings and things like that, and this machine uses those waste materials to make filament, and then they can make things, 3D print things using that. And here is the very first 3D print object that was 3D printed in space. Was actually a test to prove the concept that they could 3D print functional objects in space. And what this guy is holding is a working wrench that actually is a working tool. And NASA provides this and other relevant 3D files from things they've created on the ISS or for NASA. They provide those files online, so you can actually go on and see things that have been 3D printed in or for space, including this wrench. So just quickly to build on this, I wanted to share some examples of how 3D printing is being used in a range of fields in current and emerging ways. We see 3D printing not just being used in manufacturing and engineering, but across a whole lot of industries and fields in medicine, science, education, and also community and lifestyle applications, all sorts of things. So I just wanted to share a few examples of different fields and different ways, different problems that 3D printing is helping to solve. So 3D printing as a technology enables us to rapidly prototype, so create things really quickly and iterate, make small changes quickly. So for example, McLaren Honda, the racing team, obviously every second matters when you're trying to be the fastest racing team on the planet. They have a 3D printer in their pit, so they can create really quickly new parts or replace broken things. And the other application of 3D printing in the racing industry is around prototyping some of the innovative and bespoke parts of the cars. The steering wheel in this car that on my screen costs over $1 million to produce. It's highly innovative, it's highly secret, it's the special design for McLaren Honda. So obviously you want to make sure that you're getting this right before you go and produce $1 million product. they use 3D printing to create a prototype, a version to test to make sure they've got it exactly right before they create the actual steering wheel that's being used. So the use of 3D printing enables people to respond really quickly when they need to make stuff, much quicker than using traditional manufacturing methods. 3D printing is also finding solutions. That's supposed to say new solutions to new problems. So this example comes again from the automotive industry. And 20 years ago, new cars being manufactured had to have 4 times their own 4 times rollover strength, meaning that in an accident, if that car rolled over on its roof, it needed to be able to withstand 4 times its own weight without crushing or collapsing. But in more recent times, that regulation is 20 times. So a car has to be able to hold 20 times its own weight on its roof, which caused a challenge or a problem for the automotive industry. How do you make something that's that strong but still light enough to not affect the aerodynamics and performance of that car in negative ways? The answer to this problem came through 3D design and 3D printing. So 3D design enables the use of much more intricate and technical geometric shapes and designs. And in 3D modeling software, the professional level software, there's a feature called topographic optimization, which is a really complex arrangement of geometric shapes, which is just not possible in traditional manufacturing techniques. But it was that technique that enabled them to design a car chassis that could withstand 20 times its own weight. So new solutions to new problems and making things safer. 3D printing in manufacturing is being used to increase performance and improve productivity. What I have on the screen here are actually some handbag handles from Louis Vuitton. So every season, Louis Vuitton will have their new range coming out, and they make most of it in-house, but some of the aspects of their accessories and their clothing are outsourced and made especially for these designs. So these little buckles on the handbag straps are outsourced and made by another company. So the idea of that can hold up the production process if you're waiting for another company to provide all of these special little buckles and whatever they are. So what they do now is 3D print a placeholder. So you can see the one on the far right is the actual end product. The others are a 3D printed replica. It's a placeholder. They can go ahead and do all of the other steps of the manufacturing of their bags, get through that more efficiently and quickly, and then just add those other special bits in once they've got them. So it's improving performance and productivity. We talked a little bit already about how 3D printing is being used in the medical world, all sorts of amazing applications. This is Colleen, and Colleen is in her 50s, and she lost her external ear in a car accident and was living with without an external ear and felt like she had to cover it with her hair and felt really self-conscious and so on. So what her plastic surgeon was able to do with 3D printing was to make an exact replica of her right ear and then reverse it and 3D print a prosthetic ear, and that was exactly like her ear. So we've had prosthetics in the past, but they don't look as natural or as real. So once this was grafted onto Christine's face, it grew over, and it was actually very difficult to tell, Colleen, I mean, it was actually very difficult to tell that it wasn't her own ear. Also sort of medically related, but being able to provide access to expensive things like prosthetics and medical aids in much more affordable ways. So here we have a child with a prosthetic limb, particularly in places like United States, where it's really it's the healthcare system makes it very expensive for children to have these prosthetics, access to prosthetic limbs, or in developing countries where children cannot access these sorts of devices. There's a company called Enable and other companies like it who are making these prosthetic hands and arms for less than $100, and they're able to give them away for free. So one of the problems with traditional prosthetics is that they're really expensive, exclusive in many parts of the world, and children grow out of them quickly. So it's very difficult for children to have equitable access to these sorts of devices. But with 3D printing, they've found a mechanical hand that's cheap, light, easy to use, and much more affordable, and much easier to provide access to people that need it. Just another medical example. I know this looks like an ice cream sundae, but it's actually a 3D model printed by a surgeon, and what the white part is a kidney. The blue part is a tumour growing on that kidney, and the pink and purple parts are the blood vessels and so on. So what the surgeon was able to do was, from the scans of this problem, was able to create a 3D printed model to be able to practice the surgery, to plan what they were going to do, to have everything set up before they went in to remove this tumour, and subsequently reducing the risk, reducing the time and the invasive process of medicine. There's heaps of examples like this, and my favourite one relates to co-joined twins. So I read about a surgeon who was preparing for an operation to separate co-joined twins, usually a very risky, very long, invasive operation. So he created a 3D print of the area where the babies were joined, and was able to once again practice, plan that operation, set up rigging and stuff before going in for that surgery. So much quicker, much safer, and much more likely for that to succeed. So lots of great examples from medicine. People in many industries are finding 3D printing solutions to environmental problems, and to be doing things that we need to do in more sustainable ways. An example of this comes from a French airplane manufacturing company, and they were able to create a nozzle, once again with these really intricate geometric designs that's only possible in 3D modelling, a fuel jet nozzle, which dramatically reduced the emissions that this airplane was bringing into the environment. Mass customization, which seems a bit like an oxymoron, but this is the first 3D printed shoe from Adidas. So mass customization, as in we can still produce a lot of these things, but we can customize them too. So this particular shoe was made for a particular sports team. So it's mass in that we're going to print 20 odd pairs, but it could be highly customized. Whereas using traditional manufacturing techniques, you're probably not going to be able to make a special shoe for a football team or for a particular type of foot in that way. So if you have $7,000, you can buy a 3D printed Adidas shoe. It's also, people are being really creative and innovative with 3D printing and thinking about entrepreneurial ideas, but also ideas that help people. This is a wonderful jeweler who is replacing heirloom jewellery that's been lost in natural disasters and war-torn countries. So this particular example comes from Syria. It's a family ring that was lost during the war. But they had a photo. There was a photo that still existed of the grandmother wearing the ring. So this is a 3D printed model in plastic of the ring, and then they went on to create this with silver or gold. And you can also 3D print in metal, such as metal and gold too. disaster response. This image comes from the earthquakes in Nepal back in 2015. And if you look closely on the bonnet of that four-wheel drive, they have a 3D printer. And this team went into Nepal to use the 3D printer to help replace damaged infrastructure, including pipes, water pipes in the area. Not only that, they were teaching the local community how to use this technology to be able to respond and fix things themselves. So they were creating that capacity as well. And then interesting to use new technologies to learn about the past. This example is a dinosaur skeleton that was uncovered in Nebraska in America, and it was a dinosaur skeleton that hadn't been found before. So it was a really important part of understanding the past. So the paleontologists found bones to create of 80% of this skeleton, but then they were able to use 3D design and 3D printing to create the rest of the bones and predict what they were going to look like, so they could understand what this particular dinosaur looked like and how big it was and how it fitted with the evolution story, etc. And 3D printed food, which I've mentioned already. A lot of the applications of 3D printed food are aesthetic. You can make really cool desserts and chocolates and things. But an example I've heard of that I thought was very actually useful was in an aged care facility where they were 3D printing a roast dinner. And it sounds gross, but you can imagine if you're no longer able to chew your food well, so you're eating puree and there's not much fun going on in the aged care home and you're missing the Sunday roasts, they were able to create a meal that looked like roast beef and vegetables, smelt like it, tasted like it, but it was still created using the pureed version of the food, but the 3D printer made it look like the meal. So I thought that was an interesting application of 3D food. So just to finish up on that, when we're talking about 3D printed objects, whether it's a house made out of concrete or cement or a Louis Vuitton buckle or a prosthetic limb, the process is the same. So we start with a digital model, which is made in some kind of software. It could be Maker's Empire. It could be a more professional or technical CAD software or computer-aided design. So we create a 3D digital model, and then the digital model is saved or downloaded as what we call an STL file. So that's a universal file type that 3D printers read, just like we have PDFs and JPEGs and docs. The STL is just the name of the file type. And in case you're interested, STL stands for stereolithography, which was the first type of 3D printing technology developed in the late 1980s. So we have our STL file, which is then taken to what we call slicing software. And every brand or model of printer has its own slicing software. It takes that digital model and it literally slices it into many layers. And then it creates the instructions, so the tool path and the slices that the 3D printer needs. And it sends those instructions for each layer to the 3D printer. We often hear 3D printing being called additive manufacturing, and this is why that the digital object is taken and sliced into many layers, which are then built layer by layer by layer in an additive manner. What happens after those instructions go to the 3D printer depends on the type of 3D printer and materials that we're using, and Luke's going to talk about that shortly, but then we end up with our 3D model. So what I'm going to do now is very quickly show you what this looks like from a Maker's Empire point of view, and then I'm going to hand over to Luke to talk about what he talks about all day, which is 3D printing in schools. Okay, so what I wanted to show you, here's an example. Here's the last thing that I made myself in Maker's Empire. I really like making coffee mugs. I make them all the time with teachers. So here is my my coffee mug that I have made in Maker's Empire. I'm just going to hop out of my presentation for a minute and go into our teacher dashboard. Here we go. So I'm in my teacher dashboard, and if I wanted to 3D print my coffee mug, I need to create this STL file for the 3D printer to use. So I'm in demo class 2. My student is called Alfie. So there is Alfie's mug. I'm going to click on the mug. Well, there it's loading. And when I get that design up, there's a button called Actions. Here we have it. It's just loading a 3D version. There you go. There's my 3D printed mug. The little happy faces there are the notes that I created on it, which I can talk about another time. So click on Actions, and then there's a bunch of things you can do here. I'm going to click on Download 3D Files, which is what you need to do if you're going to do the 3D printing yourself. If you are asking Maker's Empire to 3D print this for you, you'd click Order Print, and that would access our print bureau or make shop. So go to Download 3D Files, and a message will pop up saying, yep, we know you want those 3D files. We're going ahead and creating those for you. And if you wanted to, you could then go through the rest of your class and do this process for all of the designs that you're wanting to 3D print. So what happens then is those 3D files will be waiting for you over on the left-hand side of our teacher dashboard under Print Manager. So if I go in there, I want to look at my 3D files. And here are all of the things that I have been downloading that I've made. That one's quite amusing, the ink thing, just because that's a history project we did with the National Trust, and the ink thing's actually an inkwell, but kind of cute that it's called the ink thing. Anyway, so here's my coffee mug. I go to the little download files cube with a download arrow, and that's going to give me a bunch of options. So I can see there that I can download the STL file, which is what I need for the 3D printer, but I can also do things like a GLB file that will create a 3D version of my design, which I can put in things like PowerPoint if I want students to use their 3D designs in some kind of presentation. And it's worth mentioning that although we're talking about 3D printing this afternoon and Maker's Empire is set up for 3D printing, you can also use the creations that students make, or they can use them in a whole range of ways. So it's about creating all sorts of different things for different purposes. So you might not need to 3D print everything. In fact, you won't want to. So you could use the files digitally. So we have the GLB file. My OBJ file is still generating, but that's for use in other digital spaces, maybe for VR, things like co-spaces. Then we can also create an AR poster, which generates a QR code so that people can scan the QR code and the student's object is then viewable in augmented reality. Great for things like designing playground equipment and seeing what it would look like, the piece of equipment would look like in the school ground. And a JPEG file is simply a screenshot of that image, of that design that you can use in presentations and so on. So the STL file is the one that I want, and you might have just missed that zooming up to my downloads folder, but that's just already downloaded there, sitting waiting for me on my computer's download folder, ready to send to that slicing software that we talked about. And I'll hand over to Luke now. The slicing software, I don't think you're going to go through that tonight, Luke, because it really depends on the brand that you're using, but Luke definitely provides training and support using the slicing software for the printers that we use, or for the schools that we work with. So Luke, I'm going to hand over to you now to talk a bit more about the actual 3D printer as a piece of hardware and that process.
Okay, thank you, Mandy. I'll get you to share.
I'm working on it. There you go.
Awesome, thank you. So Screen window. Yes. That's,
Thanks, Mandy.
You're welcome.
I think this works. Sorry, I haven't actually used Teams before.
Oh, right up the
So
top.
share.
Share right at the top next. There you go. Good.
So that'll hopefully, does that work?
Yep. Can see
Yep,
it.
awesome. Awesome. Okay, well, yes, hello everyone. Thanks for joining us. So my name's Luke. I'm the hardware specialist at Makers Empire. So I do the dispatch and the training and the documentation and the support for any of the 3D printers that customers purchase from us. As Mandy said, there are obviously a whole range of brands and models and types of printers that you can get. What we generally see in primary schools, either through ourselves or through other resellers, is the FDM type of 3D printer. So FDM just stands for Fused Deposition Modeling, and it refers to the technology and the way in which the printers create your objects. So an FDM printer is similar to a computer-controlled hot glue gun, if you could imagine that. So with a hot glue gun, you poke a stick of glue in the back, and then it heats it up and pushes it at the front, and it can use that to build up objects. And that's exactly how these printers work. So I'm going to go through this printer here, which is the Adventurer 4 3D printer. It's the printer that we recommend for schools for a couple of different reasons. One is that it's got a pretty generous build volume in comparison to the size of the printer. So the printer itself is the size of a desktop photocopier, if you could imagine that, and it's got a build volume of 220 by 200 by 250 millimeters tall. So that's the physical size of an object that you could replicate inside of this machine. This one's also optimized for printing in PLA, which is the plastic type that is recommended for primary schools, and we'll have a chat about that a little bit later. And as a pro, the Adventurer 4 is also capable of printing ABS, which is a petroleum-based plastic that we generally don't use in primary schools at all. However, some high schools do use it because it's more of an engineering type material. Apart from that, a couple of the other features for the Adventurer 4 is that it's got automated filament loading and calibration, and I'll have a look at that a little bit later. There's an automatic time-lapse mode, a quick change extruder nozzle, and it's also best-in-class reliability. So we generally find a success rate of the printing in the Adventurer 4 anywhere of sort of 95% and up, depending on sort of the training level and whether you're a new user or an experienced user, and that sort of thing. And then the last thing I wanted to mention is that it's got a built-in carbon and HEPA filter, and it has a 1 kilogram material capacity. So when you buy material, you'll generally get a kilo at a time. So this machine is made to house those inside. So first off, I'll have a quick chat about PLA filament. So like I said, that's a filament that we recommend for primary schools. And the main reason for that is that it's a non-toxic biodegradable plastic made of cornstarch. So they'll basically take cornstarch, they'll add a little bit of pigment, a little bit of color, and then they turn it into this biodegradable filament, which is sort of like whippersnipper cord. So it's this long, thin piece of plastic that we then feed into the printer, and it'll basically heat that up and squirt it out below onto the platform, and it builds up your object layer by layer. PLA is compostable and recyclable through companies like D-Cycle, which is a company specific to Adelaide, and they specialize in printer waste collection, and they recycle and turn that into actually new filament for printers, which is an awesome concept. Is there anything else, Mandy, that I should mention about PLA?
Just that it's gluten-free.
Yeah, it is indeed gluten-free. Yeah, yeah. We once had a school who had a student who was highly allergic to gluten. They couldn't physically touch it. So we know for a fact that it is gluten-free if you've got any allergies like that in the school.
And I guess you could just quickly say about storage without going into too much detail.
Yes. Good thinking, Mandy. Thank you. So yeah, there are two main parts to the storage of filament. And this goes for any filament in any school, but it's especially important for the PLA filament. So like I said, it's a biodegradable material, which means that in a sort of moist or humid environment, or in a hot sunny environment, it will start to biodegrade. With that said, we normally see a good lifetime out of these objects of usually a few years before they'll start breaking down. But for that reason, when you're storing this material, it's really important to store it in a sealed environment. So what that basically means is that if you're not going to be using the filament for more than a week or two, it's recommended just to put it in a Ziploc bag, seal it off, and that'll keep all of the moisture and the air and whatnot away from it, and you'll get a better, or rather a longer lifetime out of the material before it sort of goes off. The second thing is that just like a whippersnipper cord, if you let go of the end, it will unravel itself. So in this image here on screen, you'll see that around the rim of this black holder, we have these little holes, and that's for tying off the filament. So when you're not using it, you poke it through those holes, and it keeps tension on the roll, so it doesn't unravel itself and get tangled. Yeah. So automated filament loading calibration. So with any printer, there is always some form of calibration that's needed. What we generally do when we're calibrating a 3D printer is that we are measuring the distance between the nozzle, where it squirts out the plastic, and the platform, where you want the object to be stuck to and build up from. If the two are too far apart, what it means is that the plastic won't get stuck onto the platform, and it'll probably just ball up somewhere, and it could cause issues. Vice versa, if the nozzle's too close to the platform, the plastic just simply won't have anywhere to actually come out from, and nothing will come out of the printer, and it'll get sort of backed up on the inside. So for that reason, calibration is really important with all 3D printers. Thankfully, the Adventurer 4 Pro is automated. So you measure 1 point, and then the print head uses a laser to basically measure the rest of the platform. And it can effectively create a 3D sort of representation of how level the platform is, or if there's any, nuances or differences in that level, and it can use that to sort of augment the first layer of your print to make sure it's sticking down just right. The other part of that is the automated filament loading. So obviously these printers use that PLA filament like a hot glue gun. They need to squirt it out. So when we're loading filament, you will need to basically feed it into the head and then push it through the nozzle to sort of clear out the old filament that might still be stuck in there. So some machines, that's completely automated, where you've got to feed it through tubes and press levers and stuff to release tension and feed it through, that sort of thing. But with the Adventurer 4, it's automated, so you just push it through the extruder intake, and the printer will basically take care of the rest and clear out all the old filament and do that sort of thing. One of the beauties, oh sorry.
Sorry, how often do you calibrate? Every time you print, or like just reasonably often, or how often do you calibrate?
Great question. So it'll depend on the brand of the printer. They all sort of have different quirks and reliability sort of metrics. With the Adventurer 4,
we have two Adventurers, so yeah, we just.
Oh, perfect. Yeah. So if they're living in one location, you generally just calibrate once, and then they'll be fine. If you've got them on a cart where they might be, moving between classrooms, in that case, I'd want to calibrate sort of every time I move it. But in general, if you're ever having issues with adhesion, where the print isn't sticking to the platform correctly, the first port of call is calibration, and that'll usually 99% of the time solve that issue, and you sort of be back in business from there. Yeah.
Great, thank you.
No worries. One of the other features of the Adventurer 4 is it's got an automatic time-lapse mode. So it's a built-in functionality. You just need to toggle it on and off depending on what you're doing. And the beauty is that if you plug a USB into the front of the machine, you can just hit download, and it'll transfer that file across for you. So you can see here, this is one of the time lapses from us doing a whole raft of those cardboard screws, if anyone's seen them. I think they call them make do or something. I can't quite remember. But yeah, it's a really nice sort of little bit of learning that you can add to presentations and whatnot to show people the formative process of your object, which is quite nice. One of the other features is it's got a quick change extruder nozzle. So in some of the older style printers, everything's sort of hardwired and bolted in and that sort of thing. So changing over when you get a clog or if you wear out a nozzle or something used to be quite a task. You'd need a lot of tools and a lot of knowledge, and you'd have to be really careful not to do anything wrong. But modern printers like the Adventurer 4, everything is sort of plug and play. So you can see here on the front, there's two levers. If you squeeze them together, it'll release the head, pop it out, and then you just click a new one in, and you'll be good to go again. They come in sizes of 0.3, 0.4, and 0.6 of a millimeter. That's the physical width of the nozzle, so basically the width of the plastic that's coming out of the head. By default, we use the 0.4, which is just a happy medium. But if you'd like more detail, you could use the 0.3. And if you want just larger, quicker prints, you could use the 0.6 as well. But yeah, the 0.4 is pretty common on most 3D printers these days. Now, from there, like Mandy said, once you've got your 3D file ready to go from Makers Empire, you'll receive the STL file, which is a universal 3D printing file. That'll work on any brand and type of printer in the world. Once you've got that, you obviously need to put it into a software that's going to create the instructions for the 3D printer. So for the Adventurer 4, we use FlashPrint, which is the software that comes with the printer. And that's what creates the instructions. So once you've popped your STL in, you can see here I've got a little dog that's been loaded in. You can do things like scaling, rotating, cutting, that sort of thing. So if you want the dog to be, twice the size, you could scale it to that. Or if you sometimes get a file from a student that's just far too large, you can also scale it down as well to print in a more reasonable time. One of the other things that FlashPrint does, is it allows you to add supports. So if you have a look at the dog in the bottom image, you can see all of these sort of vertical pillars underneath, sections of the dog. Whereas in the first one, we don't have any of that. So supports are a sort of scaffold structure that gets built up around an object to hold it up while it's being printed. The general rule of thumb is that anything that prints vertically, layer upon layer, is perfectly fine. But as you sort of go further out and you get things sort of more in the mid-air type areas, that's when supports become really important. Because if you're going to be pushing out hot, gooey, soft plastic into mid-air, obviously nothing's there to catch it, and it'll end up looking like a bit of a spaghetti monster. So the supports create a scaffold that build up around it to catch those sorts of mid-air sections and allow them to sort of stay solidified in the right spot while they're printing. So once you've sliced the file, you'll have generally what we call G-code, and G-code is simply just a word that we use to refer to the instructions for the 3D printer. So I'm not sure if you guys can see it very well, but in the top image here, you can see the dog is in sort of this orangey pinky color. The support material is in this blue color. There is a purple raft at the bottom. And then in the second image, you can see this sort of yellow structure on the inside. So what you'll generally find is that the printers are really material efficient, and that's because they print mostly hollow. So this honeycomb structure on the inside of the dog gives it plenty of strength for being used and tested and iterated upon, but it uses up to about 85% less plastic than if it was printed solid. The other thing about the software is that up in the top right rather of both images, you'll see an estimated print time. This one is a massive dog, so it's going to be a 9-hour print. That'll be an overnight print, and it'll use 91 grams of plastic. So you can use that to help, I guess estimate the sort of cost of these objects. And if you want, you can also bring that into a literacy part of the project in terms of costing out student work as well, which is quite nice. Yeah, so basically once you've got the sliced file, you just need to transfer that to the printer and you'll end up with the finished object. Sorry, I forgot to get rid of that text there. But yeah, so this is the finished dog. So you can see the dogs all form together correctly. and then we've got these big log zigzag sections of support material. So that's what we refer to as tearaway support. So with most printers, you'll generally get a pair of pliers or something, and you can just grab one end of that and it'll go bing, 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 and it should come off the surface and you'll be left with whatever you originally intended. So that's the general process of how a 3D printer works. They will all work in a similar fashion, but they might have different softwares and sort of different steps within that sort of process. But yeah, they will all work in a similar fashion. So next up, I wanted to have a chat about some statistics that we have from different schools who work with us regarding their 3D printers and their 3D printing journey. So in terms of the number of printers in schools, by far the average is 1 to 2 printers. That's generally the sort of lowest cost of entry, but we do see a reasonable percentage. I think it's about 30% or so of schools who will bump that up. And that's usually something they'll do in later years. So most schools will buy 1 or 2 printers, and then they'll work on just getting people trained up. They'll work on integrating into curriculum, that sort of thing. And then after usually a year or 2, we notice that they generally then want to move into getting 4 or 5 printers and sort of building that capacity around what's capable. In terms of moving the printer, we find that the majority of people simply don't move it, and that's a really good idea. When you move a printer, it can introduce new issues, things that calibration could solve, but I think most people prefer to just leave the printer in one location because it just sort of prevents issues like that from cropping up.
Where's a good location for the Adventurer, Lou?
Good question, Maddie. So the Adventurer 4, because it's a completely sealed machine, it can actually go anywhere you want. Actually, let me jump back. Yeah, it can go anywhere you want. So older style machines, things like the Inventor 2S, which is the predecessor to the Adventurer, because that didn't have a heated platform and because it wasn't completely sealed, it was really sort of open to the elements. So if you had a window open or if the aircon was switched on, that could negatively impact your printing ability. Thankfully, though, with the Adventurer 4, because it's completely sealed, it can really go anywhere. I'd recommend finding a stable table or desk for it to live on. But apart from that, yeah, it doesn't matter too much, thankfully.
And because of the inbuilt filters, you don't need to worry about other ventilation, do you?
Yeah, exactly right. Yeah, that built-in HEPA and carbon filter takes care of any nasties that might happen to come out of the machine. Thankfully, because it's PLA, it's non-toxic. So yeah, you'll be right in that sort of respect. Yeah. In terms of who uses the machine, we get a pretty good mixture between teachers and students using them. So you will come across some schools in which it's just the teachers using it. And then we do actually have some schools as well that have almost exclusively students using the printers. And that just really comes down to how well you can implement things like the flash print software and how well the students can learn all of the sort of processes and sort of ins and outs of how the printing process works. But yeah, it's a really good mixture of teachers, students, sort of all working together to bring the printing to life. The most common print size, this is an interesting one, because as you can imagine, the size of the print indicates, or rather it impacts the time that it's going to take to print the object. So that dog that I showed you earlier, that is sort of jumbo sized for us. So we usually print things between 50 to 100 millimeters in size, whereas that one was about 200 millimeters. So it was a jumbo size, and that was taking about 9 hours. So you can see here that a good percentage of schools print at less than 50 millimeters and between 50 and 75 millimeters. To print above 100 millimeters or 10 centimeters is pretty uncommon in most schools, because at that point, yeah, you are looking at sort of 5, 10, 15 hour prints, whereas anything less than 50 millimeters or 5 centimeters, you'll generally see that within an hour or so. depending on which machine that you've got. And then I think this is my last point here, but printing multiples. So that's another question we do get asked sometimes, is can I print multiples? Because if you've got a class worth, if you've got 25 50mm size prints and they're all going to take an hour each, you might set one running overnight and then an hour later it'll be done, and you might have wasted that night. So you can actually print multiples. So within the printing software, you simply load up as many of the student works as will fit in the machine, and the software will take care of the rest. And it can print them all sort of sequentially, print a layer on this one, the next one, the third one, and sort of go through in that fashion. And it means that you can be a lot more efficient on time, because if you've got, 10 prints and they all take an hour each, you can send that overnight, and then in the morning you'll have 10 prints ready to go. For a reasonably small amount of work and sort of input and getting them running. Yeah, so I think that was my last point. Oh no, sorry, that's right. Here we go. So this was the other point I was going to make. Sorry. So filament rolls. So that's another question that people do ask is, how much is it going to be costing to run this machine? How much are we going to be paying? Are we going to be blasting through materials, or is it really efficient? That sort of thing. So you can see here that almost 50% of schools only use 1 to 2 rolls. So that's 1 to 2 kilograms. And those rolls are about $30 to $40 each, depending on where you buy them from. So you're looking at generally about $50 a year in material in order to run these 3D printers. Apart from that, I think that was my last slide. Yeah. Did anyone have any questions?
No, all good, thank you.
Awesome.
Luke,
Okay.
my question is, what's the most important thing to get right to enable a successful print?
That is a really good question. Before I answer that, Mandy, have I stopped sharing?
Yes.
Oh, okay. I didn't actually click anything. It's working like magic in the background. Awesome. Yeah, so really good question. So the most important thing is calibration. So when it comes to the printing process, the success of your print relies almost entirely on how well your 3D print sticks to the platform. If it doesn't stick correctly, or if it maybe sticks but only a little bit well, it means that further on in the printing process, it can dislodge and let go, and obviously you'll have a failed print at that point. If, however, your first layer sticks perfectly the first time, there's a 99% chance that the rest of your print will be totally fine and very, very successful. Yeah.
Thank you, Luke. I'm aware. Thank you very much for that. That was great. I'm aware that we've gone over time, but I'm just going to very quickly share some examples. If you need to leave, that's fine. This will be in the recording. So schools who are using this technology successfully are looking for ways to integrate it into the curriculum and to make the 3D printing purposeful. So they're often using design thinking to solve problems, and here's a few examples of that. So this is from Garnet Plains, the Aboriginal school in the northern suburbs, and they had a problem with water wastage in their school. They'd also looked at the First Nations relationships and traditional knowledge around water, and what they decided to do was to create some funnel type structures to add to the taps, to attach them to the taps so that water was ending up in drink bottles rather than all over the place when students were refilling. So you can see the 3D printed prototype there. A junior primary class visited the Adelaide Zoo when they were looking at redeveloping the sea lion enclosure, and they used 3D printing to improve that enclosure. But some of them made 3D printed seals and then built a new enclosure around it. Some of them added new features or structures to the enclosure using 3D printing models to create that prototype. This is Owen Primary School who were really concerned about drought and the impact of drought on farmers and farm animals. And one of the problems was that during a drought, it was very difficult for farmers to keep the drink troughs full of water for sheep. The wind was blowing the water out, it was evaporating, filling up with dirt and then becoming mud. So these students created working models of their ideas for protecting the water in sheep feeding troughs. So those couple of examples were using the 3D printing to communicate an idea, so a scale model or a prototype. These next two are actual products that were created through 3D printing. So this school, Loberful Primary School, the upper primary class wanted to help Will, who's the little boy at the front who lives with cystic fibrosis, and his problem is that multiple times a day he needs to use his nebulizer, but it's vital that that nebulizer is clean and dry before he uses it to avoid getting any moisture in his lungs. And the problem was that it was difficult to get to dry the nebulizer device in between usages. So the upper primary class developed some different draining systems, which Will is there testing using 3D printing. And the last example is Westlakes Shore Primary School, who did an audit of how water was being used in their school garden, and they found that a lot of their watering systems had leaking parts, or the water wasn't ending up exactly where it was meant to be. So you can see there the 3D printed hose connector, but also the device to keep the hose in place. And they've even used 3D printing to label the trees and plants in their school garden. So there's a little bit of inspiration, some examples that schools that we work with have been using to use the 3D printing technology in meaningful ways. So thank you for staying on a couple of more minutes later. Did anybody have any questions or discussion about any of those things that Luke and I have shared today?
No, but I really like the real world examples. I'd love to sort of investigate those a bit more and work out how we can do that kind of stuff in our school.
Oh, great. We'll see out if we can be of any help, or if you'd like to talk through ideas, or if Luke can be of any help with the actual 3D printing process. We'd love to get involved.
Thank you. That'd be great.
All right. You know where to find us.
Yep.
Okay.
All right.
On that note, I think we'll say thank you very much for coming. Please let us know at any time if we can help with any of any projects that you're working on using design thinking, using Makers Empire, 3D design and 3D printing. Thank you very much.
Awesome. Thank you so much for your time.
Thank you. Bye.
Bye.